Hello there, my name is Hamza. Today I will present my dynamics and vibrations assignment for BLM 1243. The question I selected was question 18. It's an application for the horizontal motion with applied force. The question says a 40 kilogram crate is pulled horizontally on a smooth floor by a force of 120 Newton. We are to determine first of all the acceleration of the crate itself, and then secondly the velocity after 5 seconds, assuming it starts from rest. Looking at what we're given the mass, which is 40 kilograms, and the applied force 120 Newton. Again, since the object starts from rest, the initial velocity will be 0 meter per second, and the time as we're given is 5 seconds. Since there's no friction, a smooth flow, it's 0 of course, there's no friction force. We are required to get the acceleration and the final velocity. Those two. This is a free-body diagram. We've got the weight, which is equal to mj, the mass into j, gravity, and we've got the normal reaction acting upward on the crate, and we've got the 120 Newton acting horizontally to the right, and that is the applied force. Because the floor is smooth, there's no friction force supporting the motion to the other side. Therefore, the only horizontal force acting on the crate is the applied force. To determine our acceleration, we're gonna apply the Newton's second law, sigma F equals ma. Substituting our values in it, the force would be 120 and the mass would be 40. We switch it up, so it becomes, solving for a equals 120 over 40, and that ends up with 3 meter per second squared, which would be our acceleration. Now to determine our velocity over there, we'll be using the first equation of the motion, which is v equals to u plus at. Substituting our values in it, the u would be the initial velocity, since we're starting from rest. A, acceleration, as we got it, 3 and 5 seconds. All in all, the calculation would be 15 meters per second. That would be our velocity. Final answers for the both acceleration, we got 3 meters per second squared, and that was the acceleration. And we've got the velocity, which is 15 meters per second after 5 seconds. That's our conclusion. Thanks for watching my presentation.